Modular Camera Dynamics is a plugin for Unreal Engine that extends the Camera Modifier system to allow for significantly more modular approaches to developing camera behaviours. You can set up fully custom camera modes in minutes using the collection of included modifiers, and no additional code is required. You can also create your own custom modifiers to develop more bespoke camera behaviour using the new instance modifiers that you can extend in Blueprint or C++. You can blend in and out camera modes during runtime, mix and match camera modes, and you can iterate on them during Plane Editor. This video acts as both an overview for the plugin as well as a quick start guide. Links to the marketplace page and the written documentation can be found in the video description. Now for this demonstration, I'm starting off with a blank third-person template. All I have done is gone to our plugins menu and made sure that we have Modular Camera Dynamics enabled. To use Modular Camera Dynamics, we need to be set up with a Modular Camera Dynamics Player Camera Manager. So to use a custom Player Camera Manager, we have to create said Player Camera Manager as a blueprint. So I'm going to create a new blueprint. I'm going to search for CD Player Camera Manager. Call that BP_Camera Manager. Now to use a custom camera manager, we need a custom player controller. And unfortunately, the third person template does not include one by default. So we're going to go ahead and create one just by selecting player controller. And we need to make sure we have this player controller referenced in our game mode. Now, thankfully, the third person template does include a game mode, so we can just head to our third person and blueprints folders. We can find the third person game mode. If we open that up, we can head to where we have our player controller class and select our brand new player controller, which I called BP player controller. Now, of course, all that's going to do is make sure that we have our player controller in use, but we haven't actually specified the camera manager. So we head to BP player controller or your new player controller that you created, and we have a look in the details panel. You can see we have the player camera manager class. We want to select our brand new player camera manager as that camera manager. Now to check that we have that player camera manager active, we can hit play and have a look in our world outliner and see if the player camera manager that is specified in this list is indeed your BP player camera manager, which in my case it is. Now, of course, we are currently just using the default third-person camera behaviours. Those are all linked, of course, to the spring arm that is included on the third-person character. You could remove this if you wanted to, because you're not going to be using it anymore, but I'm going to just leave it as it is because it will get overridden by the custom camera logic. And to use said custom camera logic, we need to have a camera data asset set up and ready to go. So the camera data assets, or the camera stacks, they're called in code, are going to be bundles of layered camera behaviors that are going to dictate how your camera behaves. And to create one of those, we can right-click in the content browser and search for data asset. And we want a camera stack data asset. I'll call that DA_third person. And if we open up that new data asset, you'll see that it contains an empty array of camera modifiers. Now, each one of these camera modifiers is instanced, so you'll be able to set up a new custom camera logic within these data assets. You won't have to create new blueprints for each of them unless you want to add fully custom code into them. Now, for the purposes of this part of the tutorial, I'm going to be going and creating a camera modifier stack, or a camera stack that will replicate the same kind of behavior that you would see for the standard third-person camera spring arm. So to do that, we're going to want to create probably 3 or 4 camera modifiers that we're going to use to replicate that behavior. We head to the camera modifiers array and create a new element. You'll see that we have a drop down here for all of the included camera modifiers. Now to start creating that behavior, we're first going to want to have a base position modifier. So hitting the little plus symbol to create a new array element here. I'm going to head to that drop down and choose a camera modifier position base. Now this modifier is going to be responsible for the initial source position of the camera. By default, it will source it from the eye height of the player, which is a property on the player character, or on the pawn technically. We could also choose a socket position, or we could choose a local or absolute position. Socket, of course, does require that it is a character type object. You would have to write a bit of custom code if you wanted to use a specific mesh on the character. For this camera stack, I'm very happy to use eye height because it's an appropriate height already. As this is currently set up, it would just put the camera inside of the player, which is not particularly helpful. So we're also going to want to add a new modifier, and we're going to use a distance modifier here. This modifier will offset the position of the camera using the camera's forward vector. So that's going to be based on the Generally speaking, that's going to be based on the control rotation of the player. It'll be, if you want the camera behind it, a negative value. Negative 350 is similar to what the default third-person character does. Now, to actually use this data asset during runtime, right now we're not actually utilizing anything, we're still using the default camera behavior. If we want to be using this, there are a couple ways to go about it. You could add it through code, which I'll show you how to do later in this video, or you can just head to the camera manager and we can set a default camera data in our properties here. So we hit this drop down and we can select DA underscore third person, and assuming that we've got everything set up correctly, we should see that custom camera data being active. It might be a bit hard to tell whether or not the new camera data is being actively used. So if we want to make sure we are using the correct camera data, we can head back to our data asset and we can change one of these values. So let's say we want the target distance to be negative 500. We can set update in real time. Now I want to keep adding some more modifiers and keep tweaking this camera behavior, but it's a bit tedious to have this data asset floating above the screen all the time. So what I'm going to do is close this down. I'm going to open up the camera manager, Modular Camera Dynamics editor. If we head to Window and then Camera Dynamics Editor, we can access that panel here. It'll open up this little Editor Utility widget. I'm going to dock that over here, and I will select the camera mode we are currently editing. Now, by default, this is going to show a simplified view of this editor. I find that to be useful for when you're just editing parameters. But if you want to actually work with it as if it was just the data asset in its raw form, we can turn off the simple view here and see just the raw parameters within that data asset. Now, to fully replicate the current behavior of the spring arm, we're going to want to add a couple more camera modifiers. First off, we're going to want to add a sweep modifier or a trace modifier. If we select the camera modifier sweep, basic sweep, we can see a few parameters in here, such as the start point for the trace channel, as well as the trace radius. Keep in mind the start point does not have to be the same as the start point for your position. In fact, if I set this to, say, a socket, and this will be the head in this case, and we enable the debug mode, which will let you see all of the additional data, the start of this trace point is not the same point as the start point of the camera's location. The start point of the camera's location is in orange and the trace start is in red. And you can see that because the modifier for the camera position space is listed here in an orange highlight. Now we're at a point where we have pretty much the same behavior as the standard spring arm that comes with a third-person character. But the spring arm does have a couple of extra bits of functionality onto it. Primarily, you can also use it to offset the position of the camera based on either a socket position, which is a local position, or a absolute position. Now, currently, all we have is the base position as well as the sweep modifier. If we want to start adding some more of those custom behaviors, we can head back to our camera modifier stack here, and we can add a position offset modifier. Right now, this modifier is not in a very good position. We want it to be happening before we do our sweep or our distance. So we can set the position of this in the modifier array to be happening just after we do our base position. The reason this is important is that these modifiers are getting applied in sequence. So first it will get the position base, then it will offset said position, then it will offset the distance, then it will handle the sweep. We don't want to change the order of that, because, we want to pay attention to the order of that, because stuff that happens in previous modifiers will affect the future modifiers. Now you can override these parameters. If you head to the camera modifier category and select use custom priority, then it will use the priority that you have in this field here. But by default, it will just apply with the standard approach. Now, unfortunately, adding new modifiers to this array won't initially update in real time. This is intentional because we don't want to change the order of this array in case anything is relying on it without express permission from the user. So to apply those changes, we have a couple of options. We could either just restart the game and that would apply it, or you can press this button on the top right here of the camera data editor, apply to player, and that will apply this new updated modifier to the player. Now it's worth noting there is a checkbox next to that to remove all existing camera data. This defaults to false just in case, but you probably want to have that as true for this kind of workflow, because you want to remove the old version of this before you apply the new one. Otherwise, you'll just end up with a big stack of duplicate camera data, which isn't ideal. So hitting apply to player, it will blend in the new camera, and we can see we also have the trace offset position, or sorry, the camera offset position. But right now the camera offset position is not offset because we have 0 values for this. So if we change one of these values to say 50 in the y-axis, now we have the camera offset in an over-the-shoulder perspective. Now, of course, because we have the camera's trace socket set to the head, occluding the camera's offset position won't actually trigger any offsetting for the camera by the trace modifier, because the trace is being handled from the head of the player to the camera's position. So if we occlude that, then we'll start offsetting, which is a positive thing in my view, but you could tweak it so it isn't like that. Now, there is one remaining feature of the spring arm that we haven't implemented yet, and that is camera lag. So if we head back to our camera modifiers, create a new modifier, choose our position lag. And once again, we're going to want to put that a bit further back in the stack. I'm going to want to put it before the distance. We take a look at it. You can see we have a bunch of options here. Before we actually change anything, I'm just going to hit apply to player to make sure that camera lag is actually implemented. And now we can see we have that lagged camera position. Now this camera lag is a little too intense for my liking, so I'm going to go back here. I'm going to change our interp speed modifier, which is going to be a multiplier of the full interpolation speed, to 5. And now we have a much shorter camera lag that's a little more natural. And of course, there are a lot of parameters you can use to tweak this behavior. If we wanted to, say, adjust the interpolation speed based on the distance of the target from the player, we want it to be like a non-linear interpolation speed, we can do that by checking the box next to this curve, with the x-axis being the distance from the target to the player, and the y-axis being the interpolation speed. We can go ahead and create a new value, let's say 0, 0, and we can go ahead and add a new key at, say, what's a reasonable distance, maybe 75, and we'll set that to be an interpolation speed of maybe 4. Recenter that on the graph, smooth it out, and that, once we reapply this modifier, will give us a nice, smooth interpolation speed. Now, if you want to see some more custom camera behaviors we can achieve with Modular Camera Dynamics, we can head over to the Camera Dynamics content, keeping in mind that you need to ensure that your content browsers, or whatever content browser you're using to access the plugin content, has both show plugin content and show engine content enabled. And once we have those both enabled, you can head down to Modular Camera Dynamics here, and we want to have a look in Modular Camera Dynamics content. There's the utility folder for the utility widget, and there is the camera stacks folder, which includes 5 built-in camera stack examples that you can use on your player. Now, we want to see what's in one of those. Let's switch over to simple view temporarily, and we'll have a look at our third-person dynamic camera stack. And you can see there's a lot more going on here than we have so far. If you want to see what that actually does, we can head back to our player camera manager and set the third-person dynamic as our default camera data. And then when we play, you can see we have a lot of modifiers active. So running through these in sequence, what we're doing is we are adjusting the rotation of the character based on the velocity of the character. Updating the rotation of the camera based on the velocity of the character, but only when we haven't had any player input for a given amount of time. And you can see that when I run around and I'm moving the camera, we're not doing anything. But if I take my hand off the mouse, we'll eventually, after a couple of seconds, start to see those arrows showing up, and we can see that we are interpreting the velocity of the character into camera rotations. Currently, I'm not controlling the camera at all with my controller. We're just getting all these rotations based on the velocity of the character. The second thing we're doing is getting the base position of the camera. We're sourcing that from, once again, the eye height of the character. We then could offset the position if we wanted to. Currently, I'm offsetting the target by 15 units in the z-axis. But of course, if we wanted to, we could tweak it so we have it offset in a over-the-shoulder style perspective. We are also offsetting the velocity of the camera offsetting the position of the camera based on the velocity. We are also handling some position lag, so that we also have, in addition to the velocity offset, we have some offset based on the position the player was previously. We have this dynamic Z position modifier, which is the kind of modifier you might see in something like a platformer, where we don't adjust the position of the camera until the character has reached a certain height in their jump, or we've lost a certain height in our jump. And of course, you can see some more details on how these modifiers work, both in code as well as by hovering over full tooltips. We then offset the target distance of our camera by negative 350 units. We then handle our collision trace, and then we also do some adjustment for the field of view of the character. So we want the field of view to be set to 90 by default, but we may also want to adjust the field of view based on the pitch of the camera, for which we have this pitch-driven FOV modifier. There's a lot of options in this one, but you can see as we lower the camera, our field of view increases, and as we raise it, it narrows back down to our default value. It's worth noting, if you would like to tweak any of the existing built-in templates here, I would highly suggest copying them over to a new location before you do so. The reason for that is that if you update Modular Camera Dynamics and you've modified the included camera stacks, then any updates will override your existing work. So if you're going to modify these and tweak them, copy them over first so that you don't lose anything when it updates. Now let's say we want to swap out the behavior of our camera during gameplay. For the purpose of this demonstration, I'll be using the dynamic third-person camera and the included top-down fixed angle camera for these for the two modes we want to switch between. I'm going to do the code for this in the player controller. Now we get this. If we get this mode, of course, we just have to hit Open Full Blueprint Editor. I'm just going to handle it on a debug key for tab. Now, of course, you could do this. You could do this based on any event that you want to, but we're just using this for demonstration purposes. Once pressed, we will use a flip-flop to switch between A and B. And we're going to want to get the player camera manager. Now, specifically, we want the Camera Dynamics camera manager, and there is an included node for this in the Camera Dynamics function library. If we search for Camera Dynamics, we have get Camera Dynamics player camera manager. Now, once a controller input, thankfully this is a controller we're in, so we can just use the self-reference. And using that player camera manager, we're going to want to remove all camera data. We're going to want to do this regardless of which camera data we wind up adding. We also want to add camera data. We'll do that twice. Now for the camera data asset, I'm going to want to first use the top-down fixed angle camera, since that's not the one we're starting with. And I'm also going to want to reference the third-person dynamic, since that is my default. Now these are the primary two nodes that we're using for adding and removing camera data. There is also a node to remove specific camera data by its data asset. And if we head back into the game and we hit tab, it's going to blend out our old camera data and activate this included top-down camera data. Now this applies to any camera modifier or camera data we want to use. It can be a custom one or an included one. Hitting that, using those add and remove will automatically handle all of the blending for you. Now, if you want some more custom camera behavior that is not achievable, or at least not achievable in a straightforward fashion using the included modifiers, what you can do is create a custom camera modifier, or specifically create a custom instanced camera modifier that you can then add to this camera data stack. Now to do so, if you right-click in the content browser, head to Blueprint class and search for instanced camera modifier, we want CD camera modifier instanced. Now to implement custom logic in your custom modifier, you'll want to head to the function override section, and the two functions that you're interested in, or maybe three functions, are the added to camera, modify camera blended, and blueprint process view rotation blended. Blueprint added to camera is just the standard, when this is added to camera, we fire this event. Blueprint modify camera blended is the automatically blended version of blueprint modify camera. Blueprint modify camera does work as standard in camera modifiers, but if you want the automatic blending feature, you want to override the blueprint modify camera blended. And if you use this, you don't need to worry about blending within this function as you normally would. Now, blueprint process view rotation blended is a bit of a more advanced function. This is for when you want to actually change the rotation of the camera. Not the way you would if you were using a standard modify camera. This will not override the control rotation of the player, this function will. So you need to be a little bit careful when you're using this function. Unless you are literally overriding the rotation entirely, you're going to want to calculate a delta rotation in this function and then output it with a corresponding view rotation. I will be uploading a video that goes into creating a custom modifier in more detail, but I want to keep it reasonably simple for this quick start guide. Now that covers getting started with Modular Camera Dynamics. I'll be uploading some more videos in the near future that will cover some more advanced topics, such as setting up custom camera modifiers and creating more advanced camera stacks, as well as going over some of the features of the individual camera stacks in more detail. Additionally, there is written documentation that you can find in the video's description that will go over some of these concepts in a more detailed manner.